Greetings, my name is Walter Cyprian and I am a student at UNAC. On this occasion, we are going to look at optimizing this video game using the IUM tool, in which we will use the included tool called ProfiLive. To access it, in the Windows window, we go to Analysis, and here in ProfiLive, we click on it once the tool is open. What we are going to do is click on Record. And at that moment, my game is already running, so let's take a look here. My game is already running. Now that we have it, these detailed graphs, which include everything that ProfiLive shows us here, the CPU usage, the rendering speeds, memory allocation, audio processing, and the PCI performance, all of these critical metrics we are going to analyze in depth together. To help us do that effectively, I already have a very comprehensive presentation prepared right here for us to go through step by step.
Here in my presentation, analyzing the optimization results that Profile Guard from the Unity tool gave us, I made my presentation in which it tells me that the summary of the analysis, the performance is efficient, the overall performance remains stable between 1 and 2 milliseconds per frame. This is good. Now analyzing rendering, memory, and audio. In rendering, it tells us that the batches and vertices are low, the scene is well optimized. In other words, the peaks are not high, we're doing well. In memory, it says there are no obvious leaks, with peaks in textures and meshes for each dynamic element. In audio, the system is stable, with minimal impact on performance. Now, analysis of video, 3D physics, and the network. So the video and network modules show an almost negligible load operating locally and efficiently. In 3D physics, there is constant activity in dynamic rigid bodies. When considering the nature of collisions, there are momentary fluctuations and spikes during instances of multiple simultaneous contacts. And in two-dimensional physics, there is currently no active or practical use in this specific scene. Now, analysis of the UI modules and the spikes in layout. Canvas reconstruction, significant spikes in UI, layout, and rendering due to the UI rebuilding process. And as for highly dynamic interface elements, constant and frequent real-time updates to text or counters inevitably force the entire interface to recalculate its layout. Processing costs. The increase is noticeable in batches and vertices during UI spikes. Analysis of lighting and texturing. In the Solve tags, lighting calculations are performed in real time every few frames. Now in dynamic lighting, there are periodic updates of the interaction between light and target. And in virtual texturing, the entire system remains remarkably stable, efficiently managing the individual tiles and streaming without encountering any significant memory-related issues. All right then, these are my detailed recommendations for the central processing unit and the lighting setup. For object pooling, implement pooling for projectiles and effects, and avoid instantiations during the update. When it comes to effective memory management, you should prioritize the reuse of existing lists and arrays in order to significantly minimize the frequency of garbage collection cycles, Heike. Furthermore, regarding your baked lighting setup, you should consider switching your lights from real-time mode to either baked or mixed settings to accurately reproduce those global illumination peaks throughout the scene. Now, let's review the design proposals for the user interface and the 3D special effects. you should divide the canvas, separating the static UI components from the dynamic UI elements in order to avoid full rebuilds. Optimize colliders by using box colliders instead of mesh colliders for static objects. And in the physics collision matrix settings, carefully set up and configure the collision layer matrix to effectively restrict and limit any unnecessary interactions. Thank you.